अस्सलाम वालेकुम डियर स्टूडेंट्स। आज जो हमारा टॉपिक है वो है डोपिंग एंड प्योरिफिकेशन ऑफ सिलिकॉन। फर्स्ट हम आता है डेफिनेशन। व्हाट इज़ डोपिंग? डोपिंग क्या है? द प्रोसेस ऑफ एडिंग सब्सटेंस टू ए प्योर सेमीकंडक्टर्स फॉर द पर्पस ऑफ मॉड्यूलेटिंग इट्स इलेक्ट्रिकल प्रॉपर्टीज इज नोन एज डोपिंग। ये डोपिंग का डेफिनेशन भी। दूसरा डेफिनेशन भी, addition of impurity will change the conductor's ability and its act as a semiconductor. The process of adding an impurity to an intrinsic is called doping, and the impurity is called a dopant. After the doping, and the intrinsic material becomes an extrinsic material. Practically only after doping these material is become usable. डोपिंग ऑफ सिलिकॉन, इसका टू टाइप्स भी है। फर्स्ट टाइप्स आता है एन टाइप। द एन टाइप ऑफ डोपिंग फास्फोरस एंड आर्सेनिक is added to the silicon small quantity phosphorus and arsenic each. Phosphorus and arsenic have 5 outer electrons, so they are out of place when they get into a silicon lattice. The fifth electron has nothing to bond to, so it is free to and it take only a very small quantity of impurity to create enough free electron to allow an electrical current to flow through the silicon. N type of silicon is a good conductor. Electron have a negative charge, hence named N types. When an impurity is added to the silicon without modifying the crystal structure of N-type material is produced. In some atoms, electrons have 5 electrons in their valence bonds, such as arsenic and antimony. Doping silicon with either impurity must not change the crystal structure and area. By the doping bonding process, the extracted electron of impurity atom does not take part in covalent bonding. These electrons are loosely held together by their originator atoms. ये डायग्राम आप भी दे सकता है, ये सिलिकॉन एटम्स का भी है। सिलिकॉन एटम्स विद कोवेलेंट बॉन्ड, arsenic atoms with an unbonded electron. Effect of doping on N-type material. The effect of doping on an N-type material is as follows. On addition of arsenic to pure silicon, the crystal becomes an N-type material. Arsenic material has additional electron or a negative charge. They do not take part in the process of covalent bonding. The impurity gives up or donate one electron to crystal, and they are referred to as donor impurities. A N-type material has extra or a free electron than an intrinsic material. A N-type material is not negatively charged equally. Of its atoms are all electrically neutral. The extra electron do not take part in the covalent bonding. The process they are free to move about through the crystal structure. ये आप भी देख सकता है, ये है एस बी और इसके इर्द गिर्द सिलिकॉन का एटम्स भी है और इसका कोवेलेंट बॉन्ड में एक दूसरे से बॉन्ड भी बना सकता है। दूसरा टाइप्स है पी टाइप्स। द क्रिस्टल स्ट्रक्चर ऑफ द सिलिकॉन इज अल्टरनेटेड व्हेन doped with the acceptor element. In this case, the indium, a piece of material, is not positive charged. Its atoms are primarily all electrically neutral. There are, however, holes in the covalent structure of many atoms group. When an electron moves and spells a hole, the whole hole becomes wet, a new hole is created in the bonding group where the electron left. Hole moment in effect. Hole moment in effect is the result of the electron movement. The p-type material will go into conduction with only 0.05 EV of energy occupied. ये डायग्राम में देख सकता है इंडियम एटम्स producing hole. The above figure show how p-type of crystal will respond when they connected to a voltage sources. Note that these are large number of hole, then electron will voltage applied. The electron are attracted to the positive batteries terminal. Effect of doping p-types material. The effect of doping p-type material are as follows. When indium or gallium is added to the pure silicon, a p-type material is formed. This type of dopant material has 3 valence electrons. They are clearly looking for a further electron. In p-type material, each hole can be filled with an electron. To fill this hole area, very less energy is required by electron from the neighboring covalent bond groups. Next आता है purification of silicon. Silicon purification means you have to already metallurgical grade silicon, which is usually 99% pure. Therefore, you need to purify this metallurgical grade silicon to get electron grade silicon, which is suitable for the electronic devices in the integrated circuit. A process by puring silicon of high purity to higher and more useful degree of purity. The purification process a few standard steps. The chemical transformation into volatile liquid such as trichlorosilane MgS plus HCl plus HSiCl3 H plus H2. Distillation of trichlorosilicon. The polysilicon rod by Siemens process. Crystallization of silicon rod by so many crystal growth methods such as Zucralesque CZ process, crystalline pulping, floating zone process. Each method has its own advantages and disadvantages. For instance, content of unwanted impurities, O2, carbon, etc. and the homogeneity of added doping concentration. स्टूडेंट्स बिल्कुल आपको इस तरह नोट्स भी मिल सकता है. हमारे चैनल को भी सब्सक्राइब करें और आपका हर टॉपिक का इस तरह नोट्स भी मिल सकता है.